We are going to map the exact latency costs and accuracy trade-offs of both architectures. That is how we determine which one is mathematically correct for specific applications. This level of precision relies on perfectly clean, extractable entities. You cannot build these strict relationships if the source data is poorly structured. The top left quadrant of this grid illustrates the danger. Attempting to feed messy text into a graph system means building a complex database on a foundation of sand. GraphRAG guarantees exact accuracy and total explainability, but it demands a rigorous data structuring process that many teams simply cannot afford. We need to evaluate raw system performance. What happens to system speed when these architectures are pushed to enterprise scale? The top section of this bar chart analyzes the latency of a simple one-hop factual query. VectorRAG holds dominance here, with a 50 millisecond retrieval speed, compared to Graph's 200 milliseconds. That 50 millisecond speed makes Vector the correct choice for rapid applications, where users need instant answers. The vertical dotted line marks the complexity threshold. This is the moment where user queries pivot into multi-relational three-hop questions. Zooming in on the jagged edge of the blue vector bar shows the limitation. At three-hop complexity, Vector's latency increases drastically, and the system often fails to return an answer. GraphRAG handles three-hop complexity with steady consistency, proving it can manage these connections with only a minor, manageable latency increase. Looking at the data table in the lower left corner reveals the hidden costs of GraphRAG: upfront index time and required memory footprint. The infrastructure tax is severe. Graph takes 15 times longer to index documents and requires more than double the memory footprint compared to Vector. The top right panel here shows why this overhead causes GraphRAG to break in certain scenarios. Constantly re-extracting entities is too slow to handle high-velocity real-time streaming data. While GraphRAG handles complex reasoning, its indexing tax and memory overhead make it a bottleneck for high-velocity data streams. This diagnostic flowchart helps match specific business realities to the correct architecture. Following the top teal path leads directly to VectorRAG. If optimizing for speed and your query relies on broad discovery, stay with pure vector. The left side of the spectrum provides concrete examples. Graph indexing is unnecessary for customer support Q&A. Panning right shows graph-heavy applications. If your application demands multi-hop reasoning, GraphRAG is necessary for tasks like legal contract analysis and fraud detection. For complex enterprise systems, the most effective applications run both architectures in parallel. This diagram illustrates a hybrid setup where both databases run in parallel. This allows the engines to compensate for each other's inherent weaknesses. This traces the mechanics of the hybrid query process. The vector engine retrieves semantic context, while the graph engine simultaneously retrieves exact relational edges. The bottom gray box highlights the result. The slight latency tax of parallel engines is justified by the grounded, accurate answers. This checklist summarizes the journey. Building resilient systems requires mastering the flashlight and GPS architectures. Thank you for joining Let's Decode together.